We're going to take up where we left off on Wednesday, and we're looking at net present value of two, actually. One project that cost $160,000 and the other that cost $105,000. And these are their cash flows then. And we have to decide which one's the better. And let's see, the rate is 10%. So we're going to do it kind of the long way and then the short way. And this is the number you're shooting for, and this was done using net present value, which is the Excel way, using the Excel formula. And it kind of looks like this. Let me put this up here. You will type in equal NPV, parentheses, you'll put in the rate, and then you can put in each one of the cash flows, or you can do it in an array, or what we say in a range, so that it starts with H17 colon through H22. Close the parentheses, and then type in plus and the negative 160,000. You don't need the parentheses in that last part, but I wanted to differentiate it. So what you would do is just type in plus and then the cell location for the 160, the negative 160, which is J16. And then you would hit enter, and voila, it would give you the net present value. And that's the easiest way to do it. But we're also going to kind of do it manually, so you kind of understand where all these numbers come from and know that it's just not magic. So what we want is to find the present value of each one of these numbers. And to do that, we need to use one of the tables. And we need to use table 2 right here. It's going to be for the present value of the value of 1, or the present value for a lump sum. So our first one is $40,000 for 1 year at 10%, and I need to find the factor for that. So I'm going to go to table 2, 1 period, and that is, let's see right here, right there. It's 0.90, 0.90, and we're going to type that right in there. And then we're going to go for 2 years at 10% for the 56,000. We need to find that number. And that's going to be this one right here. There's 2 under 10, and that's 8264. And we put that one right in there, 8264. We're going to do the same thing for the third year, and that one comes up to be 0.7513, and the fourth year comes up to be 0.6830, and then the fifth year comes up to be 0.6209. Okay, so now all we have to do is multiply these. So that's going to be 40,000 times the factor. So 40,000 in 1 year, bring it back to present value, is worth 36,330. We'll do that for all of them. Then we're going to copy this down. So there we have all of our present value numbers. I'm going to add those up to find the present value of the project's cash flows. And I come up with 245.66. Now, that's the present value of the cash flows. We want the net present value of the project. So we are going to subtract the initial outlay from the cash flows and come up with 85,066. We're going to be a little bit off because of rounding. Excel uses this number out 4 or 5 places, actually 5 places, and I've only taken it out, obviously, 4. So we're a little bit off, but the net present value of this $160,000 project is $85,075. It's more than 0, which is what you want. So you would accept that one. This would be a good project. Now you're going to do the same thing with this one down here. Now what is kind of cool about this is the factors you found in the above one can be the factors you use down here because they match. You're the 5 years at 10%. So now all you have to do is multiply things out. Copy down and add it up. So you have your cash flows. So the net present value of this one is $184,000 and some odd dollars. Now it has a initial outflow of $105,000. So you're just going to subtract that from the, and it comes up to $79,071. And this one, using the formula, comes up to a little bit over that, and again that's because of the way the rounding happens. So that's how you figure cash flows, both using the Excel function and by doing it manual using in tables. Now let me explain. Table 2 is for a lump sum. Table 3 is for even payments throughout. So when you're looking at uneven payments, such as we just looked at, where each one is different, you're going to use the factors on table 2. When you've got even, like you had 8 $35,000 cash flows for 8 years, you could come to this table and use this factor, and it would bring it back. So let's look at the very last one, and the very last one needs to scoot over. Let's see what I can do. See how creative I can become. It's moving. It's coming. One more. There you go. Now on this one, we're looking at the internal rate of return. And that is nothing more than at what point is the interest rate equal. Well, at what point, okay, does the net present value equal 0? And that's what this finds for you. And it gives you the return of this particular project. So now we're looking at, right here, you would type in equal IRR, and in the parentheses, and all you have to do is type out the outflow and then all of the cash flows, highlight them, and hit enter, and it does the calculation for you. The internal rate of return is 20% on this one, and the internal rate of return for the next one, let's see if this works, is 13%. And that looks like, in a formula, equal IRR, parentheses, and then I'm just going to come up here and grab those and then hit enter. And that's how you calculate the internal rate of return. Now, in this activity so far, we have looked at payback period, both even and uneven. We've looked at the accounting rate of return using net income and average investment. We have looked at net present value, and we have looked at internal rate of return. So there you have all 5 of them, and we've covered them all. We're going to cover one more in the homework, and that is the break-even payback, which is, I think, a fairly good calculation. So this ends the practice set, and the next video is going to be the homework. Alrighty, thank you.